Cool. Well, thanks for coming out. Laura, thank you for opening the doors. I always tell everybody I love the space at Project Quest. So yeah, I start up every DEVSA meetup with just a quick little news and updates. Everyone's in the Discord for the most part, so you guys see a lot of the Jesse ramblings on there. But yeah, just to share some news and updates. Let's get started here. What is DEVSA? We'll keep it simple. We're a group of developers that are working at home, learning remotely. Just wanted to get out to meet some people in person, and that's what we are. So we're a community platform that really caters. Our mission's really focused on learning and networking. So I like the other tech groups in the city, the startups and the venture capital folks. They refer to us as the techies. But yeah, if you're someone that's taking deep dives in documentation, watching videos on YouTube, in tech Twitter, this is the community for you. Yeah, as far as how to find us, if you're not in the Discord already, that QR code will take you there. But yeah, wherever I've lost track of where we're at. I think
I can tell you.
Oh, we're
a number.
Give us a number, Sean. Our mathematician will give us that number. So I'll wait for Sean. What's funny with the Discord is that was really how DEVSA started. Like we went to a lot of meetup events in the beginning. We were surprised to find that there was about like 15 or so active groups in the city doing a mix of like remote in-person events. But what I found out was nobody was talking to each other. So I go to a group, everybody had the same story. Like, why are you doing this? I'm trying to do something in the city. And then we go to the event, and then like everyone is kind of event's over. It's like, what do we do now? So there was like no out of the 15 or so groups, one had a website, one had a Discord, and after that, I was like, you're just kind of on your own. So we created the Discord as our first little step to kind of just have a central location for people to find each other.
348.
340. So flirting with 350, close to 400. So that was step one. Just kind of have a platform that people can connect and go from there. And then the next phase was our community calendar. So again, our goal at working as this central hub is making it easy for you to find the other tech groups in the city. So if you are not subscribed to that QR code will take you there. But our whole idea with the calendar is you don't have to go to Meetup. You don't have to go to Eventbrite. We've taken the time to find those groups. And we've even filtered out the ones that are not in San Antonio. So for example, there's this Gen AI one, like Gen AI San Antonio, and they do virtual events, but the group's out of Atlanta. You research the organizer. She's blasted all of Meetup and Eventbrite with Gen AI events all over the US. So we are making sure that the groups that we're spotlighting in our calendar are actual active tech groups in the city. So you go to the calendar, you're going to see everyone's events. What's funny is the last Thursday of the month has become like a really busy day for events. So for example, next Thursday, there's 4 events happening and they're all in person. So you're going to have from like Bitcoin Club, you got the DEF CON group. Who else is it? You got SA New Tech, and it's all on the calendar. But again, this was our goal of trying to act as that one hub to find other techies in the city. And as far as events go, what's lined up next for DEVSA? We have our first event with UTSA next Wednesday. So UTSA reached out to us. They're launching a game development program. And they saw that we were doing events focused on learning and networking. And they were like, hey, can you help us out and do some like game development talks at the school? And we said, sure. So we'll be at main campus next Wednesday from 2 p.m. to 4 p.m. The events that we're going to be doing at UTSA, the whole idea behind it is they really want it to be more geared towards folks that want to learn about the game development program that they're officially launching in the fall of 2025, but doing a soft launch now. So that's our event next week. This is our official October event. Wasn't planning on doing an October event because we have a lot of moving parts that we're juggling right now. But I had somebody reach out and said, hey, I want to do a talk. I want to do it on this. And I was like, okay. So We're going to be doing an event on blockchain, but more so the technology used behind the scenes. So we have a speaker who owns a company called WebZ. We're going to integrate the Bitcoin Club, but they'll be going over the open source tools that are out there, cloud. The person's going to be speaking using Next.js and Supabase. They'll be going over tools like that and how they're used in the blockchain space. October the 19th is the date. I just haven't put that on there yet. But again, the calendar to Discord will give you the information. Excited for this one. We're going to be doing this in October as well, but this is going to be a reoccurring standalone theme through DEVSA. We call it Indie Hackers. And we're going to be doing it at a space on San Pedro called Zelif Cam. I'm wearing your shirt, that's where I work. So we'll be doing it there. But the whole idea with Indie Hackers, it's really more of a mindset when it comes to building. And the whole mindset is building quickly, shipping products quickly, trying to leverage potential income through SaaS applications. But we're, a lot of it's focused on a lot of the tooling that makes it easy to build fast and ship fast. So a lot of the Vercel products you'll find. But we'll be, the team's going to be here. We'll be meeting up there on Friday nights, about 3 or 4 hours, just kind of see what people build and just follow along in the Discord to see if they ship it. And we'll just kind of circle back to those every time. But Indie Hackers, super excited for that. I just wanted to spotlight this. The first print will be available on October the 1st, but there is going to be a print-only magazine coming to the San Antonio techie community. So with that, we're going to be doing a launch party on October 1st. So if you're not in the Discord, be there and you'll get all the details there. But the QR code will take you to a link where you can see the rules for submitting. But it's going to be a printed mag. They call it a Zine. Influenced by 2600, and the articles that you type out, they're not shared online. It's strictly living only in print form, and it's gonna be free, and it'll be coming out monthly starting October 1st. Had a meeting with the Geekdom team today. We're ready to go live, but they shared. So as far as the Geekdom link, they reached out to DEVSA, said, we want to give you a space. I think all of us were caught up in excitement because I was talking to Charles, the CEO, Nick, the main marketing manager, and it was like 24/7. We'll just share a temporary key in the Discord. It'll be easy for everybody. And then Monica, who's like the operational manager and the compliance person, she was like, we can't do it. We got to slow it down, guys. So the way this is going to work, and in our Discord, we have a dedicated co-working space channel now that I'm going to want to leverage, but there's going to be 5 admin keys that I'm going to be able to give away. The venue space will still be open 24/7, but the admin key will be the person that allows people into the 6th floor space. So my goal is to reach out to the partners that we have, like a Project Quest, if we ever want to do anything like a resume review. What else we talked about? We can ideas like Leak Code Club, mock interviews, stuff like that. But I'll be reaching out to partners, people in the community, anyone that's working remotely that has that schedule that can kind of take them there, just to try to make that space as open as possible during the 24/7 period. I get out of work at 3 o'clock. So if we had a part, and these will all be conversations in the Discord, but if somebody was able to start the day, that could be like a consistent source, I can go in and get tagged in to kind of close out the day, kind of that working idea. And then, but yeah, that's going to be the big thing is there'll have to be one of the admins will have to be there for the space to be open. But yeah, it's so cool. Still excited. It's a great space. I know everybody talked about parking downtown. I did a lot of research on parking. Central Library tends to be a winner. It's a 10-minute walk from the library to Geekdom. They offer 3 hours free parking, 5 hours for the day. And if that 10-minute walk is too crazy, especially with the heat, Via Link is out there to do $1.30 bus rides. Or not even bus rides, just like a quick little like Uber kind of style van. But $1.30 rides to get around downtown San Antonio. And it's on top of a Chick-fil-A. There's a new pizza joint. You got a really nice bar underneath the place. You got Pinkerton's barbecue across the street. Like it's a really cool space, and it's on the historic Houston streets. You got Riverwalk and all of that stuff. So it's a really great space to explore. This has been the big one I've been talking about. It's officially happening November 15th. Venue got moved. So this event's happening at Techport. But with this event, it's an all-day event. But what I'm going to spotlight from the DEVSA side, from 10 a.m. to 5:30 p.m., we will have a dedicated room, and we scheduled tech talks for the whole day. So I'm really excited. It's a lot of firsts as far as who we're going to be presenting. But outside of the DEVSA community room, if you just go explore this event this day on November 15th, there's going to be a dedicated tech startup room with their own talks and panels, venture capital room with their own events, and a tech demo room. So if anyone's built a project, an MVP they want to kind of demo in front of somebody has a startup tool they want to show off, we'll have demos running throughout the day. And there'll be food and drinks and all that stuff's going to be included. So, and there'll be a bunch of vendor tables. So we invited a bunch of community folks to go out there and set up a table and just say hello. But yeah, I'm excited. Some of the talks we got planned, I have everything from cloud native as far as like security on that end. We have somebody that uses Python for a hardware rig. And they make music videos using Runway, which is a text-to-video AI prompt, Midjourney, and some other generative AI tools. But I'm really excited to see that demo come to life. So we're like, how are we using Python and those tools to make music videos? So cool little block there. Towards the end of the slides, I'll quit talking soon. This is more just like a fun project for me. We have a dedicated pop-up shop. If you do see it, so the QR code will take you there. There's a lot of Python logos. If you see that, ask yourself why. Python Software Foundation gave us the green light to sell the logo commercially. So we're like, thank you, and went all in on the Python brand and logo. But I think there's some really cool designs. I think there's a lot of fun stuff. If you think you see something you like, feel free. If not, nothing personal. But the shop is a thing. And with that said, that's been the DEVSA news and updates. So before we bring on Sean to start the talk, I wanted to give Laura some time to kind of say hello, tell us about Project Quest.
Hi, good evening, everyone. My name is Laura Torres. I'm an alumni relations and career transition coordinator here at Project Quest. Project Quest is a nonprofit organization that helps people pursue training in healthcare, trades manufacturing, and IT cybersecurity. And so we've been around for over 30 years. We're a relatively small organization. Some of the other workforce development organizations have hundreds of people. We have 50. So we're small but mighty. Right now is a great time if you know anyone who's interested in pursuing a training within the city of San Antonio, because the Ready to Work initiative. So we can help with a variety of different programs for certificate, associates, or even bachelor's as well. So there's always new partners joining with Ready to Work. St. Philip's just joined the catalog with their bachelor's in cybersecurity, and so those are great opportunities for people. It's a really great time for education and not having to pay for it. And so at Project Quest, when you go through a training, you're also partnered with a career coach that checks in with you every step of the way to make sure that you complete your program. And then we also have our employment team that helps you find a job within that area. So I'm part of that employment team because alumni are sometimes in job search. And so the only other big thing that we have going on right now is the Big Give. So if you type in Big Give is a day of giving in the San Antonio area for nonprofits. And so we are part of that. Our staff has different teams that are competing. And if you get the top prize, you get an extra day off. So,
Nice.
So if you go to Big Give, Project Quest, find the Inside Out team, that's my team.
Nice.
We can also donate to the general Project Quest. But all in all, we're just very thankful for you all for being here. The space, there's other smaller classrooms too as well. We're very grateful for Jesse for for hosting this event. We're happy to have you here. If you have more questions, feel free to ask me after. I'll be here till the end. So thank you all for being here. And then pizza and snacks in the back there. Please grab some. And then you walk past the bathrooms when you walked into the main doors. So
Awesome. I appreciate it, Laura. Thank you. Awesome. I really do love this space. But with that said, Sean, it is time.
All right.
So I'm excited to introduce my favorite mathematician, recent UTSA master's graduate. But he had a talk scheduled at UTSA for the Rowdy Hacks team. And that was going to be an intro to machine learning. So I just got to throw it out there. Hey, want to do a little test run? He said yes. But it's going to be an intro to machine learning through the lens of a mathematician. I know there's a lot of numbers in there. But thank you, Sean. I'll give you a second to get plugged in. I'll play some audio to maybe not make it so silent. But thank you for being here. Were you able to get this thing to work?
All right, well, I guess this thing is real now, huh? Before I begin, I do want to thank Laura and the folks at Project Quest for having us over here. Also want to thank Jesse for inviting me to do this talk. And as he said, it is going to be basically a mathematician's guide to machine learning. So first, just before we begin on the actual meat of this stuff, just want to kind of introduce myself, like who I am, what I've done. So I am a mathematician by trade and by study. I got my undergrad in math at Texas A&M University San Antonio in 2015, while also simultaneously getting a teaching certificate for grades 7 to 12. So I've been in the classroom, in and out of college settings as well. I taught at St. Philip's for a time, as well as in college in Bryan. Then I just finished my master's degree in applied industrial mathematics here at UTSA this past spring, so hooray. And I also studied briefly at Texas A&M University in their industrial mathematics program. So I've also done some optimization stuff, a lot of statistics, industrial engineering. I was in their department for a bit too. We have a joint thing with them. But what am I really? Right now, I am an operations research analyst at Randolph Air Force Base with ATC, the Air Education Training Command. We focus on pilot training, and we just do a fair amount of projects for different stakeholders within the Air Force. And yes, I am a former musician, played trombone in a quarantine band. We can talk about that later. Hope you guys like ska. So we all know, or rather, we've all heard machine learning. It's been the zeitgeist for a few years now. But it's actually quite a relatively, I guess, old idea yet modern. It's been around since like the 50s as kind of a concept with the multi-layer perceptron. I believe it was a paper by Rosenblatt in the 50s or 60s, I can't quite remember. But there's a few ways to really think about what machine learning really is. So one of the texts that I have in my digital library, Mathematics for Machine Learning by Dijkstra, which is available for free. They have a GitHub page. You can download a PDF copy of it, and you can also view it in your web browser. Machine learning is about designing algorithms that automatically extract valuable information from data. So think about the age that we live in now. Lots of data coming at you. Everything from stock prices, news, so like news headlines, even video, images, right? Audio. That's all information. Okay, you can talk about it however you want, but sometimes we want to extract information from those data sets to like gain some insights. Now, I also looked at IBM's site, and they define machine learning as a branch of computer science that focuses on the use of data and algorithms to enable AI, artificial intelligence, to imitate the way that humans learn. So machine learning is a subset of artificial intelligence. Simply put, it's just how computers learn from past experiences. Now, with that, like a lot of people, and especially some of my computer science students, have mentioned, yeah, I want to get into machine learning, I want to get into AI, I want to get into data science, and then I say, oh, talk about taking linear algebra. A lot of them, yeah, no, we're not really required to take linear algebra. I'm like, you should really consider it, because it's really the cornerstone of not just modern mathematics, but really machine learning. It's all linear algebra, and I promised myself I wouldn't say the T word, but tensor algebra. Sorry, you guys can hear the T word. I think we'll bleep that on post. So let's just play a little game here. Chihuahua or muffin? All right. This is like a nice little toy meme data set here, you know. And think about this, right? You have a bunch of images. You want to classify them into, in this case, 1 or 2 groups. They say nice Chihuahua, like we have in the 1.4 entry. So that is a Chihuahua indeed. This one's also a Chihuahua in the 1.5, but this one in the 1.6 is a muffin. And of course, we as humans know what a Chihuahua is. All right, small dog, kind of like pointy ears. Honestly, I think this one's my favorite here. But we know how to do that. We can pick out features of these things, right? So the question is like, how can we train a computer to actually extract these features from data? And so there's just going to be 2 goals for this talk here. This is a shortened version of what I plan to give out routing hacks in the next month. So I want to make sure that we understand the basic mathematical framework of machine learning. And we're just going to look at some very basic supervised and unsupervised learning tests. So that's usually how we classify machine learning tests. Okay, supervised learning and unsupervised learning. We'll get into that. So let's just begin with the mathematical framework. And I really want to, probably some of you go, well, what is he going to really talk about? Well, there's going to be some calculus here. Not really much. Just differential calculus. Wow, that was hard to say. So take derivatives, max, min. Okay. The word gradient comes in. You probably have heard that because of gradient descent algorithms. Some elementary probability here. And other aspects which I would love to talk about: linear algebra, numerical analysis, topology, even though I know no topology, functional analysis, so infinite dimensional vector spaces and like. We're not really going to touch that. I'll probably mention some linear algebra on the fly, but I can give you some nice ways to learn about that, especially linear algebra. MIT has a course on that, 1802, I believe it is, or 1806. Which is by Gilbert Strang. You may have heard his name float around the mathematical space. So really, at the heart of a lot of these algorithms is an objective function, okay? You may have heard as a cost function, or in general case, a functional. So every machine learning task starts with an objective. We want to minimize some mean square error, okay? That's in the case of linear regression. We want to maximize our accuracy, okay, classification tasks. We want to minimize or maximize something. So these kinds of things are certain objective functions, mean square error, okay, MSE, likelihood, or really log likelihood. We want to maximize log likelihood to estimate parameters. Cross entropy for classification tasks. Okay, we want to do stuff with that. Okay, and the idea is we want to maximize or minimize those functions subject to some constraints. So, for example, like in the very, very easy case, that picture that we have there on the left is a very basic convex function. You'll hear, if you look at the literature in machine learning, they usually talk about convex optimization, which are like the nicest kinds of functions you can do stuff with. And even more so, not just convex functions, but convex and differentiable functions. Those that are differentiable everywhere. We're going to look at slopes. So we want to find max or min, or like even a region, okay, where we have a max or min, okay? And of course, we want to find these minima. So these are just going to be like a basic result here. So if you have taken calculus, for some of us it may have been a long time, longer than others, derivatives, remember, are just like slopes, rates of change. And if you think about max and min, okay, we were told that, yeah, to find max and min, we just take derivatives and set them equal to 0. But the problem is, when we say that if you have a minimum, okay, and that the derivative is 0, that's only a necessary condition. That's not enough. Okay, so just because the derivative is 0 doesn't necessarily mean you have a minimum. We don't have a sufficient condition. We have to have something stronger. Okay. So you have to like avoid these like points of inflection, saddle points, okay, where maybe you do some like weird bendy stuff and the function isn't actually a max or a min at that point or in that neighborhood. So we actually have to add this second derivative. So some algorithms, for example, Newton's method, which is a common root finding algorithm, requires your function to be C2, meaning you have two derivatives and they behave nice enough. So you need this second derivative, and if you want a minimum, the way I've always phrased it is if you look at your function, okay, concave up, you have a minimum, smiley face. Whereas for maxima, concave down, frowning face, maximum. So you have these conditions. And in fact, having a second derivative is enough. In fact, if your second derivative is positive and your first derivative at that point is 0, you have enough information to say that you have a minimum. So of course, we don't always get that. So you got to kind of relax it. And there's some other aspects in analysis, in mathematical analysis that we can go into, but we won't. But of course, we still have to like find these minima. So the question is how? Well, I just said in the last slide, you take the derivative, set them equal to 0. Okay, great. We know how to solve equations, asterisk. Okay, if they're like a very simple linear equation, it's easy. If it's a polynomial, you can factor. But what if you have these weird objective functions, maybe with like stuff like logs and exponentials and other weird functions, elliptic functions maybe from a differential equation application maybe. Well, now you have to like kind of estimate where it is, and now you have to like find this through minimization algorithms. So you may have heard of gradient descent, stochastic gradient descent, two of the most common algorithms in machine learning and in optimization. And basically what you're trying to do is you're trying to step in the direction in which the derivative, the gradient, changes the most. So imagine that you're like trying to climb down a mountain, okay, you're going to look around you, figure out where you can go down the fastest, take a step, okay, and then reposition, reassess, and then keep going until you get to a minimum. Okay, so here I have an image from Chopra and Canale, a staple text in numerical methods for engineers, where they actually visualize gradients ascent. So instead of going to climb down to the bottom of the mountain, you're climbing to the top of the mountain. You're always trying to move in the direction of the most change. But of course, there's many different gradient descent algorithms. So which one do you pull off the shelf, right? You look in scikit-learn, you look in SciPy, you look in all these libraries, PyTorch. Okay, there are lots of optimizers out there. There's Adagrad, Atom, SGD. Okay, so the thing is, you want to choose the tool that's right for the job and your data set, right? You can't just say, oh, I'm going to apply stochastic gradient descent. Well, yeah, randomized algorithms work great. They really do. But the problem is, you have to like really tweak the step sizes, the learning rate, as you may have heard called. You need to tweak them so that you actually get convergence, which has a technical definition, just basically thinking is close enough. You want to tune that so that you actually don't, let's say, overshoot or wiggle back and forth and miss a min, or you actually get convergence. So you can fix that with, say, batch gradient descent, which gets you the which changes the gradient after the whole data set has been gone through. So you go through your training set, update the gradient, move on. It's stable, but if you have a very, very large data set, I'm talking like, say, like maybe like 10 to the 12 or something, 10 to the 12 data points, it gets really slow. So you have to really find a way to go around that. Adaptive gradient descent changes the step size progressively, so you may shrink your learning rate. Okay. And the moral of the story is just find the right tool. You just gotta figure out what tool is going to be right for your data set, depending on its structure. One optimizer may be great for one application, one might be good for another. And I found that myself while looking at physics-informed neural networks. It was not fun to do some of the training on that. So with that math background out of the way, okay, so you've heard me say these things from calculus, okay, and I've avoided linear algebra for the moment. We're going to look at supervised learning. You may have heard this term before. So what is supervised learning? So imagine you have a labeled data set, okay? So like you have data and you know the labels, okay? Red and blue, okay? Yes or no. Cancerous, not cancerous. Chihuahua or muffin, okay? You're giving the machine the information it knows, and now you're trying to like have it learn and pick out patterns. So from this figure, from an introduction to statistical learning with Python, which is this version of the text was just released in Python. It was originally in R, and it actually is a free textbook for you to use. Use the Python one if you like. The R, a lot of people can like the R one because it's R, but I like R if you know the statistical language. We have data in 3 different groups, and we've linearly separated them. So you can say we have the green team, the yellow team, the blue team. Okay, and the question is, how do we actually get the computer to learn it? Okay, the labels are acting as the teacher. Okay, you're supervising, you're overseeing its learning. You may have heard of regression. That's for continuous outcomes. So like predicting a temperature based on previous data. Classification, our Chihuahua or muffin thing, that's looking at categorical data. Depends on what your output is. And regression is, I think, really the most simple supervised task. So we may have seen it from maybe an algebra class or stat class a long time ago. Way to think about it in the plane is, let's say you have a bunch of data points. Maybe the X values are like, say, I don't know, income, and the Y value is, we can think of any like continuous response. And the question is, if we plot that, can we find a line that best approximates the data, that best fits through the data? It doesn't have to fit through all the points, it can't do that. It's just gotta go, like, give the story, capture the trend, if you will. So here, best, well, that's an optimization word, right? You want to be the very best, like no one ever was. Here, best means we want to do a minimization problem. We're trying to minimize a sum of squared residuals. We have heard observed minus expected. So what you saw versus what the model predicted, you're going to take that difference and square it. Those are our residuals. And since we're trying to fit to a line, you may remember y equals mx plus b. I'm actually going to call the line beta 0 plus beta 1 xi. Okay, where beta 0s are intercepts, beta 1s are slope, or rate of change. But the thing is, we're used to like x and y's being our variables in algebra class, right? Well, here, our variables, I'm calling this cost functional j. This cost function j is a function of beta 0 and beta 1. We're trying to find this intercept beta 0 and the slope beta 1 that best minimizes this thing. So how do we do that? Well, you can easily solve this through vector calculus, or if you're cool, you can phrase this as a matrix problem. Use matrix derivatives. And I'm just, you can consult any standard text. They may leave this as an exercise in calculus text, but basically the slope is related to the covariance of your data divided by the variance of your input. And beta 0, hey, that looks like the equation of a line almost, doesn't it? Yeah, it's based on means as well. So this is a solved problem. There's not really much learning to do. You can actually write this up using your favorite linear algebra library and solve this problem. This is already built in R, in Python. C, and C++, yeah, you got to do some work, but you can probably call in the packages and you can do it. So there's not much to learn. There's a tiny solution, but imagine if you have big data. I'm talking like 10 to the 6, 10 to the 7. You have like 10 to the 7 observations and maybe 100 features. That's a very hard problem to do. Matrix multiplication runs at the order, if I believe, n cubed. So imagine the number of operations you have to go through for matrix multiplication. And imagine the number of operations you have to go through to actually solve this with matrices. So instead, we can take an approach using scikit-learn, one of the most popular machine learning libraries out there, available in Python, pip install sklearn. So the way that it's done is instead we're going to do these trained test splits. So you may have heard that before. We're going to take about, say, 70% of the data, use that to train and build our model. We get some stuff, okay, great. And then we're going to test it. We're going to fit the remaining 30% on it. So we avoid doing all this matrix nonsense, okay? All this linear algebra stuff using like maybe SVD or QR, and I will be doing a talk on SVD soon, maybe on my channel. We'll see that. Please like and subscribe. But also please like and subscribe to DEVSA. So the thing is, we can actually get closer to true linear algebra solutions. So I've actually done this with one of the data sets that is available in scikit-learn, one of the common introductory data sets. This is from the diabetes data set, fitting for me. That data set has a bunch of features, but I just want to restrict this to two. So we have a BMI along the x-axis, and then a target measurement. I believe that's going to be like something like a target. I believe it's supposed to be a blood sugar to reach. And I want to see, is there a linear relationship? Well, it looks like a cloud, but like there is some trend, a positive trend. Larger BMI, you want to have a larger target. And I've actually done the regression using the normal equations, the equations from algebra in red. And I said, okay, scikit-learn, do your stuff. I got it in green. Pretty darn close, right? We don't actually have to solve the entire problem. And we even split this up into our training data in blue, and then we fit it in the orange. Okay. Basic supervised learning task. But a not so tight task is classification. Red and blue, right? I hope nobody's colorblind. There is red and blue colorblindness, right? So pick your favorite two colors. So like maybe A and B, yes or no, on a binary classification. The question I have here now is, can I easily separate this data? If I didn't already have the colors, can I easily separate this data into two groups, and figure out which point belongs to which group? And if I have a new group, can I predict which class a point go into? That's another supervised learning thing. Okay, so we train it on this. And there's many ways that we can do this. Logistic regression, it's another regression technique, but now instead we're doing this on an odds ratio, so we get a probability that a new point fits into class red or class blue. You can do support vector machines, which is based on minimizing the distance to a separating hyperplane. You may or may not have this linear separation. You can do different kernels. There are many papers out on that. Decision trees, you may have heard these as well. Basically, a bunch of yes or no questions. And then nearest neighbors, really one of my favorite, and like the easiest to explain. And it just makes predictions based on nearby data. So the same data set, I took that same data set before, and now I'm just going to run these three different algorithms. On the left, we have logistic regression. Okay, we have some of the points in blue are still classified as blue, some of the points in orange are classified as orange. Then you have some of the red points that got misclassified. It's gonna make mistakes. It's not gonna be perfect. Okay, there's some unobservable error that you have to estimate and minimize. The middle, we have nearest neighbors. Basically, you take each training point, look at its three closest neighbors, and if it's, think about your own neighborhood, right? Everyone's gonna kind of have the same thoughts on the HOA or that dirt bag that has the lawn or the whatever. It gives a different accuracy because this is a different algorithm. SGD, you can do a stochastic gradient descent classifier, which I honestly didn't learn about. I actually didn't know for a while. But three different algorithms, different classification results. You can figure out which of the red misclassified points are missing from the other ones. So again, moral of the story is make sure that you choose the right tool for the job. Okay. So that's all supervised learning. Well, there's a lot more of it. But of course, we also have unsupervised techniques. So what is an unsupervised technique? You're learning without labels, okay? Basically, it's like a set it and forget it. You give the computer the data, then you just say, have fun, peace out. That's it. No labels. It's like, telling a PhD student to learn about their advisor's thesis topic. So it's like, oh, fine, okay, do a Google search, buy the book, don't understand it, look at a few papers, decide you want to drop out of the PhD. That's not happening to me yet, rather. So, for example, this unsupervised techniques, this is like figuring out similar dog breeds, right? Just certain dog breeds have similar characteristics. Like Chihuahuas, they're all tiny enough, pointy ears, right? German Shepherds, huge. Terriers or poodles or Shih Tzus or whatever. I have a lot of dogs at the house. Yeah. Ask for pictures. Spotting shapes and images to detect objects, and in particular, so that's feature segmentation, like for self-driving cars, or finding patterns of medical imaging, right? Is this a tumor or is this just whatever? So there is no human element. You set it and forget it. And I grabbed this from the Google for Developers page, testing out clustering algorithms. This is k-means, similar to k-nearest neighbors. You look at the nearest k points, get some sort of average, and you're trying to estimate a certain center of mass if you've done physics or engineering. And if you look at the picture on the left, the unlabeled data, well, let's actually do this. How many classes do you see in the unlabeled set? Anybody, how many classes can you probably see? How many distinct groups?
3.
2, 3. I honestly think I thought there was 2. I thought there was 2. If I were to linearly separate, I'd probably go through this gap here, but if you
I
give
can
it
see the other one at the same time now.
yeah, if you give it 3, right, you say maybe there's 3 clusters here, it's going to try its best to find 3 clusters. Give it 7, it's going to try to find 7. So clustering and unsupervised tasks can be pretty hard. So you got to make sure that like you know what you're doing. Again, find the right tool for the job. But the cool thing is, notice that everything that we did was in the plane. Most of your data sets may not have the same geometry, okay? They may not live on the usual Euclidean manifolds that we're used to. Fancy differential geometry word for funky shape. So, for example, you have a donut, okay? You're looking for enclaves. Okay, you could have like 2 U-shaped things that kind of intersect. Scikit-learn has a picture that demonstrates how some of these different unsupervised algorithms work on different geometries. And so there's a lot of work being done in topological data analysis where now we use the geometry of our data sets. Okay, so you can even use this for, say, singular value decomposition and image recognition and image processing. You can do this for, to think about dimensionality reduction, going from like 100 variables all the way down to 2. Okay, and of course, we all know, I've heard about neural networks, right? Deep learning. Thing is, constructing these neural networks, you can build your architecture, your linear layers, choose your activation functions, right? Use a CNN for image classification, whatever. But finding one and combining that with like all the other algorithms is an artist. So what am I really trying to say here? Machine learning is such a powerful tool. I love learning about it. I love reading papers. I have a bunch of books on it too, and the mathematical foundations. Find the right tool for the job to do your machine learning task. And with that, I say thank you for your time and attention.
Thank you, Sean.
And of course, if anybody has questions, I can answer them.
And any questions for Sean, our mathematician?
How do you know like something is the right tool? Is it kind of like a spaghetti on the wall kind of thing to see what sticks?
Yeah, so that's a good question. So how do we know that we have the right tool? Well, again, that can be based on like cleaning your data sets, doing some exploratory analysis, especially with the problem of the geometry of your data set, right? If you want to do a classification task, but you don't have like a linearly separable data set where you can just like draw a line and go like, there you go. Well, then you got to use these other things called kernels. So you have like polynomial kernels, which may separate out by a parabola, radial kernels, which do circles. You have to like do a lot of hard work behind the scenes, try to like figure out, read the documentation, read some of the literature, ask an expert, which I don't claim to be, but especially with optimizers as well. I've trained a neural network to solve a differential equation. And numerically, I mean, differential equations we do numerically, like, you know, finite element method or finite volumes, finite differences, whatever, different numerical solvers and our favorite tools, Python, MATLAB, whatever. But for some of them, like say, simulating fluid flow or plasma actions in the vacuum, that's very hard to do. So I can actually train a neural network to do that. But the problem is, I need to figure out like what optimizer to use. So I just test in small scale, see how it performs. You know, weigh the pros and cons based on like say, is my function differential everywhere? Do I have enough derivatives? Do I have jumps? Is the geometry going to be an issue? So there's really a lot of behind the scenes testing. It's not just like, you know, pull a library and just like implement and go. I really feel like with machine learning, you have to like really just play around with it, test it, make a best judgment. There is no like hard criterion because it's an art as well as a science. You have to really do some of the work behind the scenes to see what the best tool is for your task.
Any other questions for Sean?
Yes.
Right, Thomas, do you have any examples in which in your industry or your field where you're working at currently, where you have actually applied successfully machine learning and been able to, well, obviously you can explain it to stakeholders, but where you have been successful?
So I've actually only been in my position for about, we're in September now, so about 2.5 months. I have not successfully done any large machine learning task in my project, but I do have one that I'm thinking about, natural language processing, trying to pick out keywords from a summary of safety events. Now, of course, natural language processing is a hard thing because I have to like go from like character data to like some sort of numerical thing, think about tokens and stuff. I haven't really done a lot of experience or really no experience with NLP and language models. But right now with a project I'm working on with my advisor, we're trying to construct a physics-informed neural network to simulate the flow of the flow of fluids in a vacuum. So this is actually a project with NASA. Talking about turbulent jet flows and artifact detection in plasma streams. So a lot of plasma dynamics, statistical mechanics. We could probably construct a neural net to solve some of these equations that would be hard to solve with classical numerical methods. So there's a wide variety of applications.
Nice. Thank you for the share.
Yes.
Sorry, just to clarify, is that a vacuum with the absence of like nearby gravity, or is that like?
Yeah, so like an actual, so as far as I can understand the project right now, just you have a spacecraft in the vacuum of space and we're ejecting say fluid, say fuel or whatever, from a channel, an internal tank into the vacuum of space, and then physics happens. I am in no way a physicist, mathematical or otherwise, but this does mesh well with my interest in applied mathematics.
That is awesome.
Thanks, Sean.
Any other questions for Sean? Fantastic question. Thank you, Sean. I said it earlier, but I really mean it. Favorite mathematician. That was amazing. And while Sean is unplugging, we're going to be introducing the man, Jason. Easily one of my favorite people in the community. I was very excited to learn from Jason. He's someone that was very active in the tech space that dates back to the days before geekdom was even a thing. He used to run a community group, was it Alamo Coders? What I love the most about Jason is he's always been a constant, even himself, he's always been in that constant mode of learning. And what I love the most is as he's been a champion for the open source community. I mean, even when I got stuck, when I needed help, this was a great resource to get questions answered, pick his brains, introduced Dependabot to the DEVSA website repo on GitHub. So I was like, what? That was the whole time. I had no idea. So now all dependencies are always up to date and working thanks to Jason. But with that said, yeah, he's definitely has the coolest office with all this awesome GitHub swag. Kind of working the dream job. I don't want to say too much more, but thank you, Jason. And he'll be giving a talk on, yes, we'll be giving a talk in a second. You'll have to get to the main screen. Thank you.
Thanks, Jesse. Hi, everybody. I'm Dan or Mason, Senior Software Engineer at GitHub. I also operate my own LLC. Been doing that for over 24 years. Meridth LLC. Help a lot of mom and pop shops not be scared of technology. I'd say 85% of them I direct them at Wix, so they can WYSIWYG and pay their own bills and manage their stuff. The other 20%, security reviews, process management, many other things, just so they're not scared of technology. I talked to you a lot shorter, a lot quicker, so please bear with me. I'm going to have a bias towards some GitHub tooling because I work at GitHub. Plus, honestly, most open source projects have a repo on GitHub, so that's where most of the stuff will live. Like Jesse said, one of the nice tools that's been created is Dependabot. The other one on the right is Renovate. Renovate has a lot more customizations regarding dependency management, but Dependabot has it also. You can group patches. So one of my favorite things to do is to not get a ton of PRs on the project. Is like if you have 25 dependencies, you get a PR per dependency. You can actually batch them by minor and patch revisions and leave your major revisions as a separate PR. So you can get one PR for all the minor and patches, and then that'll have like 25 changes. But as long as your tests, which I imagine we'll be talking about later, as long as your tests are in place and you actually run your tests, you can verify the dependency updates don't put it. The other tooling that GitHub provides is GAS, GitHub Advanced Security. I'll talk about why it's important for open source, because with a public repository, you get it for free. You get code scanning, a CLI tool, secret scanning, auto triage rules. So if you can write code and configurations to where the repository will react automatically based off rules you've set up in place. The big thing, and I'll talk about this in a second, about security is the more automation you have in place, the more your developers will love you. Because when a developer critiques another developer, we're all like, heck no, don't you dare talk to me. But when the tooling or the automation yells at them, they're like, okay, fine. And we all know that because we all have the same reaction. This is death by text, but here's a pretty picture. So if you have a public repo or you have a private repo with GAS turned on, you get all these features. If you have a private repo without GAS, you obviously don't get it. Again, this is going to be a lot faster than we're talking. Buzzword bingo, we've all heard of shift left. So the idea is to take security mentality away from post-deployment to pre-deployment. So put in automation, put in the PR, the brief, the code scanning, all that stuff before the code ever leaves the shop. We've all heard about supply chain and how those have been infected by malware. And so this is a mentality that the industry is going through right now. And I'll be honest with you, it's still pretty new. A lot of developers do not think about security up front. They hope that tooling will do it for them. And GitHub, bias at work there, has done its best to provide that for these people. That's the security side of it. There's a bunch of other tools there. I know at the dev thing coming up in November, ChainGuard is a component. ChainGuard is a great tool for trying to create your base container images to make sure CVEs and security updates have been applied to the base images, and then you can base your applications off those base images. A little pricey, but it's worth the money. They do a really good job. But that's one of the ways things get infected is you have not done your security updates in your production environment, so people and hackers find their ways in. All they need is time and patience, they'll find a way in. Now I'm talking about community open source, which I'm very passionate about. I maintain 7 projects right now. One of them is part of the Helm charts for the Argo suite. So Argo CD, Argo workflows, Argo events. We manage the Helm charts for those projects. A great resource. Sorry, I'm a big fan of Guy Kawasaki's presentations in, so I give you a slide and then I'll talk to it. My slide deck can't live without me. Opensource.guide is a website that GitHub maintains. It is an open source repo, and it literally will give you multiple feedback options or opportunities on how to manage an open source project. It has excerpts from multiple open source maintainers on how they maintain their projects. The number one square at the top left is how to maintain maintainer health. Because we all know as open source, we're not getting paid usually. And people tend to be quite entitled about my PR is what needs to be merged, it needs to be merged now. This website will give you advice on how to manage that and how to do that, and that's what I'm also going to do here tonight a little bit. That, again, that repo, that website is open source. So if you want to go take a look, we could definitely use the help. The number one thing that people need to see when they're trying to contribute to open source is contributing.md. Try and have that file or a similar file in your GitHub repository, and it'll get highlighted and set off to the right-hand side. Plus, there's also a shortcut technique, and let's say at the end, that contributing MD will be highlighted for new contributors on what the expectations are. How do you set up a development environment? What do you need to go? You need to go look at existing issues first before you file your own. Before you do a PR, has somebody already done it? Things like that. Do a little due diligence in what the setting of expectations by the maintainers has been set to. The other thing as a maintainer is you want to have a code of conduct. And I need to escape real quick because I already forgot the website. Contributorcovenant.org is a great resource because the maintainer communities out there have gotten together and they've standardized a code of conduct for the world. And again, I'm going to go back to my notes. TLDR, too long didn't read, gives you steps, and you put on your repo, and it says the 4 things that will happen when somebody misbehaves. They get a correction, they get a warning, they get a temporary ban, and then they get a permanent ban. But what you've done with that code of conduct is you set expectations. In other words, don't be an a-hole. And you now have the documentation to show somebody, hey, you're being an a-hole, here's our rules, please stop. And if they don't, you can iterate through those 4 steps, and eventually, hopefully, you don't resort to permanent ban. I'm a big fan of praise in public, criticize in private. So for those kind of people, hopefully you can interact with them privately. But again, open source is public. So if you do have to interact with them on the issues, on the PRs, remember they're human too. It's a quote, I always think it's contributed to Rob Williams. You have no idea what everybody's going, you have no idea what battles people are fighting, so be kind, always. The other thing as a maintainer is over-communicate. So when somebody's taken the time to give you a pull request, don't rubber stamp it. Don't just say LGTM. I mean, it's a prefix keyword you can put in the GitHub PRs. Take the time to ask questions or highlight something that they did in the code. Hey, I'm really glad you did this. Thanks for adding a test. We didn't have that covered. You increased our test coverage. Over-communicate. And of course, thank them for their contribution. You will bring people back if you're kind. It's human nature, simple. Last slide again, fast talk. There's a pretty cool feature in GitHub that if a maintainer labels their issues with good space first space issue or good dash first dash issue or some form of good first issue, go to the repository URL and type /contribute on the end of it, and you will see all the good first issues right there. And in the top right is the contributing.md. So if you as a software developer are looking, where can I go to get started in open source? There's 2 websites already, goodfirstissues.com and goodfirstissue.dev. Both of them have done the job of parsing the GitHub repositories and grabbing all the good first issues for those repositories. And again, the maintainers have decided these are low-hanging fruit, docs, tests, simple things to get you into the open source community. But again, GitHub does have that /contribute feature on every repository. Oh, sorry, every public repository. Short and sweet, folks. Any questions? Oh, and I wanted to plug one thing. My coworker, Andy, reminded me about the good first issues today. I told her I would say that because she's the one who pointed it out to me.
Is it true that GitHub runs on GitHub?
Yes, we dog food GitHub hardcore. And before every release goes out, it goes through staff tools, so internal developers get to interact with stuff, and we beta test everything before it goes out the door. Everything is a GitHub issue or a GitHub PR. There's no Jira. Yes. Everything's GitHub.
I have used GitHub projects once, so
it's getting better. It's getting better. The toolings are getting there, and GitHub is trying to not just be a source code repository. Of course, Copilot and our AI Skynet master lords are coming. So, yeah, but yeah, good question.
What was
Yes. Sorry. Yes, ma'am.
Oh, can you share examples? Because you had mentioned at the very beginning, automation setups. Can you share an example?
I don't have any on me, but I can definitely get them to Jesse and get them to Discord. Yeah,
Awesome.
so
Thank you.
Dependabot, the docs on GitHub are phenomenal. They're religious. They stay up to date, hardcore. So Dependabot has many configurations you can put in place. A lot of my open source projects I can use for that also. There's other features that I get in place too, like how to handle Semver, how to do releases, automating all of that, all based off GitHub labels. So I can, like right now on the GitHub Actions for the OSPO, the Open Source Program Office at GitHub, if we put the release label on one of the PRs, when that merges, it causes a release of all the previous ones that hadn't gone out. We also made it to where you can manually release by going to GitHub Actions, and you go to the right top and release whatever hasn't been released. I have examples of all of that. So yeah, I can either write a blog post, which is rusty.jmeridth.com. No like and subscribe, just read. And then I can also get in the Discord for Jesse to share.
Thank you, awesome.
You're very welcome.
I was gonna ask, like, is the Renovate is just like a batch of Dependabot?
Renovate's its own tool. It's open source. It existed before Dependabot. Dependabot was consumed by GitHub. It was a company that GitHub bought. And I'm a big fan of Dependabot because it's right next to my code. Renovate is an app that would have to run. It's run by Mend, and it'll monitor your code just like Dependabot does. But the customizations and features that Renovate provides currently beats Dependabot. A lot of the open source projects, especially Argo Helm, the one I help maintain, we use Renovate because there's a lot of customizations you can do through many programming languages that will be able to automate that whole process. Dependabot doesn't have those features yet. Did that answer your question?
Yes.
Cool.
Any other questions for Jason?
Awesome.
Jason,
Thank you.
lighting and lighting talk, that was amazing, really good stuff. Thank you, Rose, for asking about the resources. I was gonna say like, hey, Jason, like, I just realized like our public group doesn't have a contributor.md file. Like, I need to get some of those resources for myself, so
I'll put some PRs up.
appreciate you. And then once I get those resources, I'll share them in the Discord. And thank you, Jason, the man. So
this company called Lean Techniques, based in Des Moines, Iowa, actually, and I just work remotely. We say we do digital transformations. I see this is controlling the mouse. So we help companies do software better. We explicitly do not go in and help you create something and then leave. Our goal is to really sometimes that's going to cloud for the first time, or getting started with testing for the first time, or just not having 15 things in progress and working overtime all the time. It's to really help and improve how stuff works. So that's what I've been doing the past few years. I'm a Microsoft MVP in .NET. And like I just said, I'm the co-organizer of the San Antonio/Austin .NET user group. Before COVID, this was 2 different groups. And then now we're acting as one group. It just started back up this year. It's pretty fresh. So please go check us out on meetup.com if you're interested in .NET stuff. It is meetup.com/sadnug. So we are the sad nugs. You can find me online at my primarily .NET technical blog, daninthecan.com. I will also be posting the slides and repo on a post there. That QR code, which I forgot to mention, was for this blog post, but it'll also be on the closing slide as well. And on Twitter, X now, whatever, and LinkedIn, I'm Daniel or Dev, both places. So please hit me up on there. It'd be awesome to see local people. So I want to start off with a short general story that actually happened to me. I imagine it has happened to other people in this room if you have done testing. Which is you have a service, API, something you're developing that hits a database. Maybe it gets, maybe it does all the CRUD operations, whatever, but you're hitting a database somehow. So in my case, it was .NET and it was EF Core, but it doesn't matter what library you're using really. And like any good obedient dev, you have to see a suite of software tests, right? And in those are integration tests. And you want to test your business logic that's trapped up in the SQL queries you're writing, right? You want to test if those things work as expected. So I write those, everything's green, and then we ship. And then what happens later? Maybe it's a day later, maybe it's a month, but in my case, I think it was a few days afterwards, something fails in production. I said, oh, I forgot to test something. There was a case I forgot to cover. But poking into it, it was not. It was something that was covered in the test, and it passed. It worked perfectly fine in the test, and it was very confusing. And really, what it was down to was I was using SQLite in my test, and in production, we were using Postgres. And I don't even remember what it was anymore. It was some little stupid difference between the engines to where the test passed in SQLite, but in Postgres, it didn't work. So I was kind of in one of the sides of the no man's land here. And it doesn't matter if you're using Postgres, right? Whatever it is. To where these SQLite and whatever your engine in production is, probably has a really big overlap. It's probably like 90% the same. But those little bits on the side, it's not the same, both features and different bugs, which is kind of worse. If you ever find yourself, use my laser pointer. It doesn't work on the TV. If you ever find yourself in one of these side regions, that's a really not fun place. You'll fix it eventually. It's very frustrating. It's very time consuming. It's just a very weird thing to fix. You have to do a lot of searching, a lot of GitHub issues of people asking questions until finally you figure out, oh, this feature just doesn't work the same. This feature isn't there. Maybe there's a bug in one of them that's not there in the other. And kind of call these false positives and false negatives. So false positives would be, your test passed, but really it's not going to work in production. False negatives is just the opposite. So your test might fail too, when it would really be fine on your production engine. And these are both really the same problem, where you spend a bunch of time and energy trying to debug this test, when really the problem is not due to your logic, it's due to different database engines. So this is my take-it-home slide, kind of, where if you forget literally everything else in this presentation, you remember only one thing, then you should remember this slide. That's what I asked. So if you're using a different SQL engine in your test than you are in production, you're testing a different system. It might be a similar system, It might be really close, but you're not testing your production system. Okay? You're testing something similar. So a lot of your tests might pass for a really long time. And hopefully this would never happen to you. But as soon as your tests do start failing because of this, then you're going to start to question all your other tests. Like, are they really passing what they should be? Are they really covering it? Okay, so why does that matter? And the picture popped up. The answer is money. Why do any tests matter, right? Because it takes us a long time to debug them, and it costs the company money. So whenever you have to pitch this or any testing stuff like this to your company, money is what they listen to, right? You spend a little more time up front writing tests and maintaining those for a lot less time in the long term. So less bugs, less defects, less rework, right? Less frustration, less working late, all that good stuff. So I think I hit all the traditional options here in my table, at least for .NET. And I think it's probably mostly the same in other languages. Maybe some of these little specifics are different, but EF Core, Native Framework Core, has something called the in-memory provider. Microsoft on their own docs actually says, hey, don't use this. Then kind of a step up from that is the SQLite provider. The advantage of both of these is that they're easy to get up and running with. But like I just said, the disadvantage of them is they're not actually what you're using for your database in production. Kind of a step up from that is, I've seen people use a real database, like put a new actual database out in dev to run your tests against, or out in prod, or maybe out in every environment. And that does work. It is the same engine at that point, but it's kind of a maintenance nightmare. Make sure if you ever update the database schema, this gets the new updates. You have to make sure the data gets cleaned up between test runs. Because it's a real database being hit with a test, only one person can run the test at the same time, right? Or else it'll get screwed up. If you are running a deployment in your pipeline that's running the tests, nobody else can run those tests even locally because it's all hitting the same database. And probably the best option on here, in my opinion, is a Docker container. This gives you the same engine as production, but it's local. You don't have to mess with anything real out there. You can really run Postgres or whatever it is in your tests, but it just all stays on your machine. So that's awesome. The big con there is that also takes some maintenance. You have to take care of the container lifecycle in your test. So starting it up, making sure it gets torn down, and the Docker file, especially if your team's not familiar with Docker files and all that. That's kind of its whole beast. Its whole own beast. So this is kind of what the people who originally wrote test containers said. They were Java developers in their case. They said, we are using Docker containers for our tests over and over, but it's kind of the same, a lot of the same boilerplate every single time. Can we just like abstract a lot of that away and automate it? And that's what they did. It's this library called test containers. And it's also, we're going to see the example for a database, but there's a bunch of modules for stuff like Kafka, Redis, RabbitMQ, a bunch of stuff. And each one of those has its own like individual configuration. You just have to know how to set up with environment variables. All the Docker files are different, right? So a test container modules, if someone else has gone out there and written that already, you just throw it in your project and it works. So here's just their logo and then some of the languages and modules they have. Neither of these are exhaustive, but on the left side, there's some of the languages. On the right side, here are some of the modules. Little concept, if I describe them in a very small sentence, they're lightweight throwaway containers. There's something about them that says you have to use them for tests or anything. That's probably their most common use case. But that's really what this library is. And this is just from their docs, a very high-level overview explanation of how test containers works. So when your test setup runs, you tell test containers to start your containers. And then when you run your tests, they actually run against the resources in the containers from the connection strings you get. And when the tests are done, you spin them down again. And this may be a little hard to see on these screens, but like I said, the big advantage to SQLite is that it's simple to get up and running. So I thought I'd just show an example. This is basically what it takes to get started with test containers. So the first line there says, hey, can I have a Postgres container? And the second line starts that container, and the third one tears it down. Like it's kind of really simple. So, like I said, the coding demo is going to be in C# and .NET, but my goal here is really, since test containers is available for all these languages, that you can kind of take this to whatever environment you're in. I'm not going to really go over these testing packages I have in here. I just added these as additional links if you want to go through the slides later and download them yourself. So let's kind of get into the meat of this presentation, which is code. I think I'm going to zoom in a little here. Is that better?
You guys have a presentation on the video to show like the.
I have it on. Yeah.
Yeah, I
But
can see
think
it.
people can see that. It's
Yeah.
just a little cramped. Let's go to 125 maybe. Okay. So conceptually, I have a pretty simple project here. My little dummy project here is I have an API that gives you information about books. So all it's got is a get book method, which gets you a book based on the name. It's got a like book method, like, like on Facebook, you can like something. You can like a book based on the ID and who's liking it, the user ID, and review book, almost the same thing as like book, except you also pass in some review content. These all just call this book service class, and all he does really is a DB context, which is our database. Probably the only notable things in this class, otherwise we just care about the test for this demo, is for a like book, we say, hey, if this record already exists in the like book table, just bail out. Don't fail, but you can't like a book more than once. We've already liked it, so just don't do anything. Otherwise, we insert that record. And review book does the same thing, except we say, we'll let you go through, but we're just going to update the review content. We're not going to add a new record. We're just going to update the existing one. So that's really all our service does. So, and for the database, just FYI, don't take this as a good example of how to use any framework. This is very simple just to get this demo working, essentially. There's just 3 tables in here, one for book, one for the book likes, and one for the book reviews. And as you can see, all I've really done is slapped primary keys on stuff, and that is it. So how I've kind of structured this demo, as you can see, I have 3 integration test projects here, and they kind of build on each other. So 1 is the worst one, 2 is a little better, and then 3, I've tried to just clean up, add some best practices, and show you, in my opinion, a very good way to use it. So we have an integration test factory, which is a pretty standard way to do integration testing in C# land. Without going into the specifics, we are going to, here's our test containers code. This runs when we start up our tests. Basically, this is that same slide I showed you. We just say PostgreSQL container equals this PostgreSQL builder.build. And this is a builder pattern. So we can, there's a whole bunch of methods in here. We could give it, if we wanted to, with database, with password, with username, all these things. We can give it a label. But we don't actually need any of these things because test containers has this idea of sensible defaults for us to where it should just work out of the box if you just build it and everything else is override. But actually, if you go to the source control on GitHub for this PostgreSQL builder, here's what it does for the initialize. So it's kind of got all these things defined for you already with default values. If I scroll to the top, here they are. So by default, it's going to use Postgres 15.1. This is probably the one thing you do want to override, so you are on exactly the same version as your production database. Everything else, username, password, port, who cares? The nice one thing about the port is that it will actually randomize this and choose an available one, so you don't run into port conflicts on your containers. So it's probably better to not set the port. Okay. So that's us telling test containers to give us PostgreSQL 1, and you do need Docker on whatever machine is running this because it will actually make Docker containers on your machine. And here is where our tests start. We say containers start async, and then we tell our TB context just to use the connection string from that test container. So let's actually look at these tests. Here's a good test. And I'm gonna, actually, let's keep that breakpoint there. I'm gonna put a breakpoint in here so that we can look at the containers. I'm going to debug that test. This test itself is pretty simple. We're just adding a randomly generated book to our database. And then when we call our get method, we say we should get that book back. Not much of a test. It seems like whenever you run the very first test in Writer, it takes a moment to really get chugging. Here it goes. So by now, our containers will be created. So I'm going to go into Docker Desktop. So here it is, and you can see it actually made 2 containers for us, even though I only asked for the PostgreSQL one. So this randomly generated, what I call it, flamboyant hertz, is my PostgreSQL one, so you can see from the image name. There's another one, and the image is test containers reuse. So what's that about? I didn't ask for that, right? Well, this gets run every single time you run test containers. It doesn't matter what you're making. It makes this by default implicitly. And this is the resource reaper container. And if you are wondering, that is a reference to the read from Death Note. That's why they named it that, because it destroys all your other containers. So the way this works in the .NET case is when the .NET process starts up, the reuse container establishes a TCP connection with it. And if that TCP connection is ever severed, it just destroys all the other containers. So I don't actually, I should as a good practice, I don't actually need to call dispose on that. If that .NET process is ever severed for any reason, let's say my IDE crashes or the .NET process crashes, and I wasn't able to dispose of my tests correctly, reuse will still clean all my containers up because he'll just wait a few seconds. He won't get that TCP connection, and then he'll close everything down. So let's just run through this. Oh, and this is just kind of cute. It doesn't actually matter. But if you look at the source code for the reuse container, it keeps basically a dictionary of all the containers so it can know what to destroy. And that variable for the dictionary is called div. So I just thought that was fun. Okay, so the test succeeded. I think just in the interest of time, I won't do it. But if you really wanted to, you could breakpoint in here to look at the connection string we got back from test containers and then log in and look at stuff in the database. Now let's look at something just slightly different. This lightbook tests. So there's 2 tests in here, just one for each case. So one case is when the user has not liked the book yet, and this method is called. Then we say there should be a single record in that book-like table. The second test says, okay, if the user has already liked this book and that method is called, we shouldn't have 2 records. We should still only have 1, right? So let's run both of these tests together and see what happens. So one passed, but one failed. The one that passed was when it exists in the database already, then it does nothing. And the one that failed was if it does not exist in the database, then it adds it. Does anyone know why? It's because we had state bleed between our tests. We didn't clean up the data in the database between our tests. So for this test, which happened to run second, we said if the book-like does not exist in the database, then it adds it. But the other test ran first, and it had already added that book-like. So this one was expecting it to not be there, and it didn't get added. So this adds a whole other problem, which you're going to have to address if you're using databases with tests anyway in some way, which is that we need to clean up between our tests, or have our tests not look at the same data, or something, so that the state doesn't bleed between the tests. And test containers doesn't offer anything for this by itself, but there's this library called Respawn. And this is by Jimmy Bogard. If anyone is familiar with that name, he's the same guy who made AutoMapper, Mediator. He's actually an Austinite. Spoke at the .NET reports.
Nice.
And this is a whole library written just to clean out a database efficiently. I don't think it says it in the docs, but I suspect it was made specifically to use test containers. Really, the only thing that's changed here is now we create this respawner object whenever we start our test as well. And we have this public reset database method. All it does is call the reset method on respawner, which will clear out everything in our database. And the way we configure that respawner is just with this. We say respawner.create respawner, give the connection string, which is the connection string from test containers. And then we tell we're using Postgres. There's a few other ones in here. SQL Server, MySQL. And then the schemas to include whatever you give it here, which we only have one schema for this, it's public. Whatever schemas you give it are the things it's going to wipe out. So if there's anything you don't want to wipe out, don't include that schema. And I don't know the internal stuff of how Respawner works, but according to the docs, it does deletes. Like it builds up a dependency graph of your databases, and it does a bunch of deletes instead of truncates, because apparently those are faster. And then we give our test access to this reset database method. So if I go to our test now, you can see I am calling this reset database method on dispose async, which will happen, if you're not familiar with .NET or XUnit, this will happen after every single test run. So this reset database happens after every single test runs. And I'll show you some performance stuff later if that sounds like it could be a lot. So let's run, the Git book test was fine before. Let's run the light book tests. And I'll run the review book test too, but those will have the same problem. It's the same issue. Okay, so those two tests passed now because Respawner was in there to clean up all the data between the tests, right? And unfortunately, it is not showing, I'm sure it's a setting in the new version of Writer that I have to turn on or something. It's not showing me the amount of seconds it took for the test to run. When I was running these on my desktop, I think it took like 3 seconds. And in my experience, it seems to take, depending on how much stuff you have running on that computer, it seems to take like half a second to 3 seconds of a one-time overhead for test containers to get going. So I think it's pretty good. Now, that's all I really want to say from that second project is Respawner. If you're not in .NET, you will need something, some kind of tool, whether you write it yourself or not, to reset your state in between tests. My third project here, I just kind of cleaned stuff up. I put a lot of the common methods I was using in this abstract database test class that all my tests were going to inherit from. So they have access to the auto fixture, they have access to the DB context in the client, they can reset the database from there. Just to make it a little bit cleaner. The tests are the same, but I have these two things I added just kind of for funsies, these lots of tests 1 and 2. And so you can, well, it might be kind of hard to see. I just copy and pasted the same two tests over and over and over and over and over again. It's where it's almost 1,000 lines, I guess. So just to kind of show you the performance of test containers. So let's just run him. And I'll just have to sort of kind of, oh, it does tell me over here on the right side, I suppose.
I think it's the cumulative.
Yeah, I think you're right, yeah. You're right with that. Well, it already finished, that seems, so if that, no, that's not cumulative, that seems right, 2 seconds. Okay, that was cumulative. So 2 seconds for 52 tests, hitting a container with a real database, that's pretty good. This last test 2 is a little more intense. It seeds, let's go up to 1,000 actually. This seeds the books table with 1,000 records on every test run and then deletes them on every test run. And there's 52 of those tests. So let's run that and see all of that. Full disclosure, I don't know how strong this little weenie laptop is, so we'll see. I think the knee-jerk response to clean up the database in between tests is kind of the performance. So almost 11 seconds, and I would say that's pretty excessive if you need to seed the database with 1,000 rows for every single test in your test suite. Actually, at home on my desktop, I did run this with 10,000, and it took a minute and 7 seconds. So not bad. Again, if you are seeding with 10,000 rows in your database in your tests, maybe you think about restructuring your test project, but performance-wise for Respawn, I think it didn't seem like there's many concerns there. So that's really it for the coding demo. Hopefully, even if you're using TypeScript or Python, which test containers is available for, this still made some bit of sense that you can get started with it. I will mention one thing to keep in mind is how many containers you are opening in your tests. So by default, XUnit, which I didn't do in this case, but by default, XUnit's behavior is to run the setup for every single test. So that would have new up a new container for every single test that I have. So I changed it to be new up a container for every single class that I have using class fixtures in XUnit. So that's pretty acceptable. That's only, if I run the whole test suite, in this case, that's 3 containers. That's probably not bad. And XUnit also offers collection fixtures, which are basically attributes you can tag your class with, and says everything in that same collection is one setup. So maybe you have 5 classes and you're fine with 1 container being shared from all those test classes. So again, C#.NET, not using XUnit, you will need to find your equivalent to whatever language, but that is something to be aware of. So I just wanted to show, here's the modules page on their docs specifically for .NET. I just kind of wanted to show all the module options. Obviously, I'm not going to go through all these, but just to show you an idea of how much stuff they have. So there's, Cosmos DB, ActiveMQ, Elasticsearch. It's not just database stuff. Kafka, RabbitMQ. Yeah, so it's a bunch of stuff. And you can write your own if you know how to do something, and it's not out there yet. It's completely open source. Speaking of open source. So that does it for the coding demo. I did not save my place in my presentation. Okay. Honorable mentions, things I think are noteworthy that did not make it into the presentation. There's this concept called resource reuse or reusable containers. Basically, you just slap a with reuse true on that container builder, and it will not spin down the container when the test finish running. What it does is it looks at the configuration you used for the builder, and it creates a hash from that, and it keeps the container running. And if it ever creates the same hash for your configuration, it refers to that same container. So I think for tests, I'm fine with spinning down containers and recreating them. But if for some reason you didn't want to do that, that is a beta feature that's available. And Podman, about a year ago or so, Docker made some very expensive price changes for enterprise. And I think got a lot of people interested in Podman. Theoretically, test containers works with any Docker compatible API. In practice, every single language version of test containers is a different repo maintained by different people. And some have official Podman support and some don't. For the .NET one, I've seen a couple people saying on Windows they got it working, I think in WSL, by setting a couple environment variables, and it works. I haven't tried it myself, but I thought it was worth noting that in theory, that should work just fine. In recap, sometimes I immediately forget stuff about the presentation when I walk out of one. So thought I'd go over it again, maybe help solidify stuff. We went over those four traditional options for integration testing with external services, namely databases a lot, test containers, what it is, why you might use it over those other ones, which is that you get to use your real actual production system in your tests, but you don't have all that overhead of maintaining it. And we had a coding demo. I showed that in C#, and I showed Respawn, which even if you don't use Respawn using another language, you will need to find your own equivalent solution for that. And that's it. Thank you. Again, this is the QR code for my blog post that has the slides and repo in there. And there's all my contact stuff again. And this looks bad because I literally just put this in here like 5 minutes ago. But this is, there's a global event called Code Retreat. And it's not profit or anything. They just say like, you can spin up your own local one if you want. So this is happening in November 9th, I think, if that's the Saturday. So Patrick and I will be there. It's basically, the idea is musicians have this thing where they get together in their garage and just jam and play music because it's fun, not because they have a deadline. So this is like the programming version of that. You pick a topic. This one's going to be test-driven development, and you try to practice that thing with the project. But the goal is not to finish the problem. The goal is to use the problem to practice test-driven development in this case. And it's like 8:30 to 5:30, so it's an all-day event, but it's free, and you get free breakfast and lunch. So that's the QR code for the first site listed there. The second site is just the general site with info. If anyone is interested. So, yeah, okay.
Awesome. Thank you, Daniel. All right, Code Retreat sounds like a good time. So with that said, that was a lot of really good information from San Antonio's Microsoft MVP. But any questions for Daniel?
Yeah. I think you were first.
Thank you. I know that the biggest, purpose at the beginning of testing to begin with is to save money and avoid wasting time. How do you strike a balance to avoid over-testing, over-analyzing? What is your, your rule of thumb?
Personally, my preference is that I have like every branch of logic in my program tested. In my experience, that bit of time writing those tests is always worth it. Whenever I haven't had them and had to instead like stay late because a defect happened. That's not always practical, maybe because the app exists already and there's no test in it. So depending on the situation and how much time you have, I think there is a balance to be struck with. Like integration tests are easier to start with a lot of times. You might hear black box testing sometimes, which is basically like, I have this app, it's already out here, but there's no test in it. But I can at least write a test that says, like for this method, if I give it this input, or maybe a group of methods, maybe just behavior. If I give it this input, I don't even know everything it does, but I know this output happens. So I can write a test that says that. And I at least know I didn't screw up behavior if I have new features, right? I didn't break anything. But if I have my way and I'm writing a new app, I test literally every behavior. And I find that's working. Right.
That was a great question.
Yeah.
Patrick, you had a question?
I saw that you used something called the async lifetime.
Yeah.
I know that's probably more using C#. Could you maybe explain kind of how that how you use its functions to be able to start and stop? I noticed that you kind of went over the starting and stopping, but
yeah, yeah, so test containers, like depending on what you're doing when your tests start up, you might not need the async stuff, but some stuff you basically need an async version of your setup, right? So test containers is an example of that. It's not something synchronous that happens. You have to wait for the container to have a certain signal, which you can choose, but to have a signal that says it's ready. So async lifetime lets X unit hook into that, basically like know when it's ready, and it lets it do an async thing, but to dispose of tests, which was our reset database.
Any other questions for Daniel? Awesome. Daniel, thank you so much. Appreciate you. Definitely. If you follow DEVSA channels, you'll definitely stay in the loop with the code retreat as we talk about venue, location, and all the fun details that come with that. But thank you, everybody, for coming out. Appreciate you. We'll be doing this again in October. If you're not following DEVSA on social media, it's going to be at DEVSATX. And that's going to be across Twitter and Instagram and Facebook. We'll be uploading some of these talks on our YouTube channel. Thanks to Zachariah from ACMSA. But definitely thank you, Sean, Jason, Daniel, and Laura and Project Quest for opening your doors. Have a good night. Till next time.